Why weak map exists beyond privacy? Weak map is especially useful when you want to attach metadata to objects you don't own. Example, const metadata equal new weak map, open and close parenthesis semicolon, then function process request argument rec open semi-curly bracket, then metadata that set argument rec comma open semi-curly bracket start time colon date.now function closing semi-curly closing. If the request object is destroyed, metadata disappears automatically. So even though we have like internal support for privacy, weak maps still support this in order for this to exist. Like for a request object that is destroyed, that metadata disappears automatically. That prevents memory leaks. In fintech backend systems handling thousands of requests, that matters. 9. What are the three examples are trying to show? Example 7.1, private counter per instance. Example 7.2, simulated private variables plus private functions. So a private counter per instance are the first example, and 7.2 is a simulated private variables. So we use a private variables, then a private functions. Example 7.3, private basket data per instance. They're showing weak map as a privacy plus encapsulation tool, not different weak map types. So basically they are showing this as a another way to encapsulate and to make things private in JavaScript. So does weak map automatically prevent bugs? No. It prevents one category of bugs: accidental mutation, external tampering, memory leaks via metadata maps. But it does not prevent logical state errors. So if you have like inherent logic issues with your components, it will not prevent that. So you need to be able to fix that. So that's more of an architecture problem. Prevent invalid transitions, prevent async race conditions, replace good design. It's a tool, not a solution. The bigger design connection. Earlier we talked about modeling state explicitly, protecting invariants, avoiding accidental mutation, managing side effects, reducing coupling. Weak map supports encapsulation, private state, controlled transitions, lower surface area, which reduces complexity. But real design maturity is thinking in state machines, thinking in invariants, thinking about failure, thinking about async boundaries. Weak map is mechanical. Design thinking is architectural. Final clarification, weak map does not resend values automatically, work like a special kind of counter, create different map types. It stores key value pairs, holds keys weakly, allows garbage collection, enables privacy patterns. That's it. First, what are hashtag private class fields? Modern JavaScript ES 2022 plus supports true private fields. Class payment open semi-curly bracket, hashtag retry count equals 0 semicolon, then increment retry function open and close parenthesis open semi-curly bracket, this that hashtag retry count plus plus semicolon closing semi-curly. So these are the same private we discussed in JavaScript that we can only access within that class. Properties starting with hashtag are truly private, cannot be accessed outside the class, cannot be enumerated, cannot be dynamically accessed, are enforced by the language. Trying this, payment that hashtag retry count, syntax error. This is real privacy, not convention. What is weak map based privacy? Weak map privacy works like this. Const underscore retry count equal new weak map open and close parenthesis semicolon, the next line class payment open semi-curly bracket constructor open and close parenthesis open semi-curly bracket next line underscore retry count that set argument this comma 0 closing, the next line increment retry function open semi-curly bracket const count equal underscore retry count that get argument this semicolon, the next line underscore retry count, that's set, argument this comma count plus 1, closing. The private state lives outside the class. The only code with access to underscore retry count can read or write it. It simulates privacy using closure. So again, it routes back to how closure in React are being implemented, like the privacy imports, privacy of classes and privacy of modules. Those are the same concept being used in higher level language. Direct comparison: A. Simplicity, hashtag private fields, clean, native, easy to read. Weak map: more verbose, harder to follow, more indirection. So it's more verbose, kind of like how XML is more verbose with JSON compared to the simple hashtag private supported by JavaScript. So winner and hashtag private. Performance: private fields stored directly on the instance, optimized by Engines V8. Weak map requires map lookup. So instead of that data being stored directly with that memory or in the engine and as well being cached, it actually requires you to look up it using a key value pair. So it's slightly slower because you're looking up third parties. More memory overhead, winner private. C. Garbage collection behavior. Weak map: if the instance is garbage collected, its entry disappears automatically. For private, private fields are stored inside the object. When object is garbage collected or GC'd, everything disappears anyway. So if that object, let's say from a third party object, disappears, that entry from that main object would also disappears. But for private, fields are stored inside the object, so you essentially need to instantiate that whole object, and that when that object disappeared, that private will also disappears anyway. So effectively equal for class-based usage. Weak map only has advantage when you are attaching metadata to objects you do not own, or like you're basically saving some memory because you're not instantiating the whole object. Encapsulation strength: hashtag private, enforced by language, impossible to access externally, even reflection won't expose it. Weak map: if someone has access to underscore retry count, they can mutate it. Privacy is by convention, winner hashtag private. Letter E. Inheritance, hashtag private, private fields are not accessible in subclasses. Strict encapsulation. Weak map: if weak map is shared in closure, can be accessed across related logic. So unlike with classes, with private, even if they are shared in closure, they cannot be accessed across related logic. Slightly more flexible. Weak map wins only in rare inheritance edge cases. So is weak map necessary in modern Node.js? In most backend systems, no. For formal normal service / domain modeling, use class payment, open semi-curly bracket, hashtag retry count, semicolon, closing. That's enough. When is weak map actually still useful? Weak map is still valuable when, first, attaching metadata to external objects. Example: const request metadata equal new weak map function, semicolon, the next line function handle request argument rec, open semi-curly bracket, next line request metadata that set argument rec, comma, open semi-curly bracket, start time colon date that now function, closing. You don't control rec, you don't want to mutate it. Weak map lets you attach hidden data safely. In high throughput node servers, this prevent memory leaks. Second, library design. If you're building a framework or reusable library, weak map allows hidden per instance data, zero property pollution, no symbol leakage, no accidental access. Framework level code still uses weak map heavily. So if you're creating a framework from the ground up, you would use this weak map because those framework extensively use hidden per instance data, and then they don't want property pollution as in zero, no symbol leakage, and no accidental access. So again, that's for attaching metadata to external objects like this fund handle request metadata that's set like start time or date now. You don't control direct, you don't want to mutate it. Weakmap lets you attach hidden data safely. So third, cross instance shared private state. Sometimes you want private state shared across instances but still hidden from the outside world. Weakmap allows that pattern. 6, from a fintech/retry design perspective, for your fintech interview, you should almost never reach for weakmap first. Instead, use hashtag private fields, enforce invariants in constructor, use explicit state transitions, make services stateless, inject dependencies. Weakmap is not design maturity signal. State modeling and invariant thinking is. Which one reduces complexity more? The goal is hide complexity behind a diff module. Both weakmap and private hide state, but private is simpler, lower cognitive load, like accidental misuse, so it reduces complexity more effectively. The real modern recommendation, Node.js, use ES modules, hashtag private fields, dependency injection, explicit state machines, immutable returns, idempotency boundaries. Avoid over-engineering with weakmap, old IIFE module patterns, manual privacy hacks. Weakmap is now mostly library level tool, metadata attachment tool, advanced internal pattern. Brutally honest answer, if you bring up weakmap in an interview and overemphasize it, it won't impress them. If you talk about invariants, retry idempotency, async boundaries, explicit transitions, dependency injection, that will. Weakmap is mechanical knowledge, design maturity, structural thinking. Are these patterns applicable to Node.js? Yes, but not in the textbook Gauff pattern way. In Node.js backend system, especially fintech, retries, payments, what matters most are module pattern, service boundaries, factory pattern, building strategies, i.e. retry policies, strategy pattern, different retry algorithms, observer pattern, event emitters, pub/sub, singleton pattern, config, DB connection, facade pattern, wrapping complex gateways. You rarely say I use the decorator pattern, but you constantly use pattern thinking. Example in Node retry system, strategy pattern, class exponential backoff, open semi-curly bracket, next delete argument attempt, then closing, the next line class linear backup, open semi-curly bracket, next line argument attempt, closing. Retry service doesn't care which one it gets. That's a design pattern in practice. So a module pattern like a service boundary within module is what matters. A factory pattern like a building strategies or retry policies or how you would construct the objects. Strategy pattern, different retry algorithms. Observer patterns, like we discussed in the previous video with the publish and subscribe, and a mediator. Singleton pattern for configuration, DB connection or a single DB connection, and a facade pattern, single or wrapping complex gateways. But you rarely say I use decorator pattern. You constantly use pattern thinking. Example in this, retry service doesn't care which one it gets. That's a design pattern in practice. Do you need JS design patterns to understand React? Short answer, you don't need formal pattern memorization, but you absolutely need pattern thinking. React is built on functional programming, composite over inheritance, closures, observer or reactivity model. Without understanding those, your React understanding stays shallow. Third, let's break React connection down. Composition over inheritance. React, layout, profile, and then closing layout like HTML tags. This is composition. Instead of class, profile extends layout. So that's what it means by composition over inheritance or extends. So why this matters? Lower coupling, clear boundaries, reusable pieces. This directly connects to service design in Node. We discussed service coordinates but doesn't own logic. Same idea. So it provides lower coupling because it doesn't really um, depend on layout. So unlike with this profile, it extends the layout. So the service just coordinates, but it doesn't own the logic. It doesn't own this profile logic, this layout. Same idea. Another is closures, which ties back to hooks. Hooks relies on closures, like function use counter, open and close parenthesis, and open semi-curly bracket, next and let count equals 0 semicolon closing. The state is preserved because of closure plus react internals mechanism. So you preserve this count state or this variable inside this function because of the closure bracket. Same idea as the private, the import, the class and module principles, and how the browser save those dependencies upon execution. I mean, just so it could contact the cache before it can return those, before it can request the dynamic imports. If you don't deeply understand closures, you'll misunderstand stale state bugs. That's why, like, removing closure, like, totally, sometimes or most often provide an error in your app. Stale state bugs. So a stale state bugs not just happen with this function or removing of closure, but also with not as well. Sometimes a not are already expired, or sometimes you expire this but is currently being used. So those are the state bugs. Dependency arrays use effect behavior. This connects to earlier when we discussed async boundaries, hidden states, invariants. So this connection to asynchronous, the try, the await and catch patterns as well, a hidden state and invariants. We discuss with a modern app. See observer pattern, React state updates. React behaves like an observer system. State change to schedule re-render. So when a state change, so that's actually how the observer works inside React. When a state change, there is a re-render. So that's kind of like, that's intuitively how observer pattern works in it. In Node.js, event emitter, pub/sub, message queues, same mental model. So yes, understanding observer helps both React and Node. So in Node.js, instead of like state change schedule re-render, what it has is the actual pub and sub, kind of like the actual JavaScript design model. A message queues, kind of like, of course, it has like a mediator part and event emitter. So it relates to the actual observer before the pub and sub. Do you need to study design pattern books? You don't need to memorize Gang of Four patterns, but you must understand encapsulation, abstraction, dependency injection, strategy. So like we have surface like a surface understanding with encapsulation. We haven't discussed that more deeply. Abstraction, we have discussed that extensively. Dependency injection, we have a mid-level, I think, because dependency injection is like the prototype, where it's like the singleton. Strategy beginner as well. State machine modeling, beginner. Composition, beginner. Immutability, mid-level. Separation of concerns, expert. So without this, your understanding stays surface level. React patterns are mostly application of functional JS patterns, not classical OOP patterns. So the React patterns are actually more of an application of the classic scripts or the classic JavaScript principles. So how this connect to everything we discussed? Earlier we covered retry state machines, invariants, encapsulation, avoiding mutation, async boundaries, event loops, concurrency in Node, weak map versus private fields. All of that is deeper than pattern memorization. Patterns are vocabulary. What you really need is structural thinking. Where does state live? Who owns mutation? What are allowed transitions? Where are side effects? How do async boundaries isolate failures? So how do asynchronous requests actually catch failures and actually not block the system? So what are the side effects that related to dependencies? What are the allowed transitions? Like inside closure, is this allowed to change the state of that closure? Is that an allowed transitions? How about mutation? Are we allowed to mutate that? Is it inside the class, inside the module? So where does the state live once this instantiated? Is this module comes first, etc. So that thinking applies to React front end, Node backend, fintech retry systems. Interview questions that could stem from this React interview. First, why does React prefer composition over inheritance? Second, how do hooks rely on closures? Third, what problem do hooks solve? Fourth, what are stale closures? Fifth, why is immutability important in React? 6. How does React schedule re-renders? 7. What happens if you mutate state directly? 8. How would you model state machine in React? 9. How would you isolate side effects? 10. How would you design an auth service? Notice these are pattern-based thinking questions. Note the JS interview questions. First, how would you structure a retry service? How would do you prevent invalid state transitions? How do you handle idempotency? Fourth, how would you model retry strategies? Fifth, when would you use event emitter? 6. How do you prevent race conditions? 7. How do you manage async boundaries? 8. How do you design for failure? 9. How do you prevent accidental mutation? 10. How do you enforce invariants? Again, pattern thinking, not pattern memorization. The real question you're asking, you're worried, if I don't deeply understand JS design patterns, will I be weak in React and Node interviews? The answer, if you understand closures, prototypes, modules, immutability, async models, state machines, encapsulation, then no. So you just need a closure, the prototype, how it copy objects, a module, a separation of concern, immutability, how like the new map metadata is immutable, how inside closure is immutable, how private is immutable, asynchronous model to catch error and not block the system, as state machines, like how an object has its own states at different level across time. Encapsulation, how would you encapsulate those values, right, to avoid kind of like related with facade, and interface and implementation complexity. So you don't need 23 patterns. The subtle mistake many developers make, they think learning patterns equal memorizing names, but senior engineers think patterns equal ways to control complexity. Deep modules hide complexity, that's the real principle. React components are deep modules. Node services should be deep modules. Retry engines must be deep modules. Direct answer, are JS patterns applicable to Node? Yes, especially strategy, factory, module. So again, module are actually also applicable in the backend. The observer type, the publish and subscribe. The factory, how would you construct an object in a node or client side, or sorry, server side TypeScript? Now, do you need JS pattern to deeply understand React? You need the underlying principle, not the pattern names. Will interviews test pattern names? Rarely. Will they test structural thinking? Absolutely. Part 1. Do you need JS design patterns to deeply understand React? So we discussed this already. Control Z. So you don't need to memorize pattern names, you do need to understand underlying principles. React are not magic, they are application of core JavaScript ideas. The real foundations, not pattern names. To deeply understand React, you must understand closures, immutability, composition, pure functions, state ownerships, side effect boundaries, like how this dynamic imports will affect this, or into what these modules and to what extents, pure functions inside the classes and module, state ownership related to module and classes, composition, also how it's related to classes extend but it's more decoupled, immutability and closures. Those are JavaScript principles. React is just a structured system built on top of them. Composition over inheritance for React, layout, open and close HTML tags, and then profile and then layout. This is composition. This is same principle as what we discussed earlier when structuring services. Instead of payment service extends database service, you do payment service argument DB comma retry strategy. That's composition, same mental model. If you understand composition in JS, you understand React architecture. Functional programming, hooks. Hooks relies on closures, pure functions, controlled side effects. Example, use effect, open and close parenthesis equal r(1) iterate open semicolon bracket fetch data function closing, and then we have this empty. So this is actually the use effects or hooks. So this use effect is the one we discussed in React, in which the side effect will only work or triggered after this function has been triggered. So as you can see, it has an empty array comma after this function. This only makes sense if you understand closures, dependency arrays, async boundaries. We also discuss async boundaries in retry logic, preventing invalid states, isolating side effects. React use effect is just a structured side effect boundary. Same principle as payment retry engine should isolate network calls from state transitions. So you should separate the calls from the state transition of your application or user application code. Observer pattern to React state. When you call set state argument new value, React schedules your render. That's reactive programming. Node equivalent, event emitter, pub/sub, message queues, same pattern. So no, you don't need to memorize observer pattern, but you must understand reactivity. The big truth, patterns are vocabulary, principles are understanding. React mastery requires state modeling, controlled mutation, side effect isolation, invariant thinking, which is exactly what we discuss in fintech retry modeling. So you need to model the state, how it is private and public, a controlled mutation, again, private and public, side effect isolation, dynamic imports, invariant thinking is like a singleton or a prototype or a parent. Part 2, React patterns versus Node retry system side by side. Now this is where it gets powerful. Let's align them conceptually. State ownership, React component owns its state. Parent passes props, no random mutation. So it has, or React implements those no random mutation by having the state inside the object not mutable, because parent can only passes props. It cannot edit or update the state of its components or child's components. No random mutation. It's also how you keep it private. You keep the closure, the classes module, and the classes and module intact. Node retry system, retry engine owns retry state. So external service cannot mutate it. Use private fields hashtag retry count. Same principle, clear state ownership prevents bugs. So those on the TypeScript backend. You have this hashtag retry count as private to control mutation. Second, control transitions. React state equal code loading to success to error. You model UI states explicitly. Node retry pending to retrying to success. So like the state on how does object change over time from loading to success plus error you basically control and model it. That's what we mean by model state transition. Same with backend, pending trying success. Like at each stage of this related and organized modules on each stage, you would model it based on that. Immutability. If you don't model state explicitly, you get invalid transitions. Same structural discipline. Third, immutability. React, you don't mutate state directly. You create new state. Node, don't mutate request objects randomly. Don't mutate retry config mid-flight. Immutability reduces accidental mutation. Same reasoning. So, in React, you might thought that you can change the state if you're inside the component, but that's not actually work. It doesn't actually mutate the state directly, so it mimics more of like a Redux, because again the state are only inside that component. The parent cannot change that. It can only pass profs on that. Side effects. React. Side effects go inside use effect. Rendering must be pure. Node retry. Network calls are side effects. State transition should be pure logic. So with side effect and React separated with rendering, in Node your side effects really is the network. So you don't blend that into the state transition. State transition should be pure the logic. Kind of like the logic must be intact, because new map won't solve the bad logic. Separate the side next state from call API. So a separate module decide next state from the call API. Same boundary separation. Fifth strategy pattern. React different UI strategies based on props. No different retry strategies, linear, exponential. So the linear and exponential are actually more of a node or server side features than a retry payment logic. Both are strategy pattern, but what matters isn't the name. What matters is swappable behavior without changing core logic or without changing core invariance. Encapsulation. React components hide internal state. Node class with hashtag private fields hide retry internals. We earlier compared weak map versus private fields. Same goal, protect invariance. Part 3, what this all really teaches. Across React and Node, you're always solving where the state live, who can mutate it, what are valid transitions, where are side effects allowed, how do I prevent invalid states. That's architectural thinking that's deeper than patterns. Your remaining blind spots. Based on our entire conversation history, your blind spots are not syntax. They are structural clarity gaps. Here they are. First, state machine modeling. You understand patterns, but you need to explicitly think in state machines. Example, instead of retry count plus plus or increment, think if states is not equal retrying, then throw an error. So that's state machine logic. If that state does not happen, you throw an error for the other object on the system to be aware that the intended logic did not go through as expected. Explicit invariance. Second, async boundary discipline. You need stronger clarity on where asynchronous begins, where state transitions occur, how to prevent double execution, and idempotency guarantees. So aside from that, since you have multiple objects, you don't just implement asynchronous to handle error. You need to know across your execution of your app, where is the asynchronous begin, where does the transition occurs of the state, like from pending to this, like the sequence or the execution, how to prevent double execution, how to prevent those transition being having two objects or double execution, or kind of like with the execution part with importing we discussed with static and dynamic import, and then idempotency guarantees, because that's the main value provided by your app. This matter for fintech interviews. Invariant thinking. You ask about patterns, but interviews care about what must always be true, what must never be true. Example, payment cannot be both success and failed. That's invariant thinking. Fourth, complexity control. The real skill, deep modules, shallow interfaces, hidden complexity. Your learning mechanisms. Now you must refine structural mechanisms. Final answer, do you need JS design patterns to deeply understand React? You need composition, like the one we discussed. Composition in React. Here, you use layout and profile and layout instead of extending it, so it's more decoupled. So composition of closures to avoid state leakage. Functional thinking, so you're thinking about function, and then not just function, is being able to re-reference that function for other app to use it. State ownership, side effect boundaries, invariant reasoning, or what must be always true, which is related to singleton and configuration. You do not need memorized pattern catalogs. Gang of four terminology. React and Node share the same core mental model. Control state, control mutation, control transitions, isolate side effects, reduce cognitive load. Patterns are tools, principles are power. So React and Node share this basic principle. They control state via closure, control mutation, avoid state leakage, control transitions, state model, so between transitions, isolate the side effects, React re-renders, and then a backend, isolate the network from the object logic or states, and then reduce cognitive load by hiding the facade inside, hiding the complex implementation inside the facade. Patterns are tools, principles are powers. Yes, your understanding is correct that rendering involves updating the UI, but it's not a single instantaneous step. React separate this process into distinct phases to optimize performance, meaning rendering does not always mean immediate UI updates. Rendering is specifically the process of calculating what the UI should look like. So it's calculating, not yet showing to the user, and the actual updating of the DOM, holding it in the UI, happens in a later, separate stage. Here's the one of your questions based on how React works. First, the two phases of rendering. Rendering in React is divided into two main phases. Render phase, calculating. React calls your component functions to figure out what the UI should look like based on the new state. This builds a virtual DOM, a JavaScript tree representation. No actual DOM changes happen yet. A component might render, but if the output is the same as before, no DOM changes will occur. So it also provides that the new state, or like sending like a duplicate state, which the inherent JavaScript feature has provided or has avoided. So it's the same philosophy for render phase of React. Commit phase, applying. React takes the difference calculated in the render phase and applies them to the real browser DOM. This is when the UI is officially upheld or updated for the user. Second, do side effects commit after the state commit? Yes, side effects, especially use effects, or what we call hook, run after the commit phase is complete. So like the empty array or bracket after the functions of this use effect. So the order of operation is state change. A component state changes, state change triggers a render. Second, render phase. React executes the component function, calculates the new virtual DOM. So as you can see, it before the render phase did not execute the component or the function inside the component until the state change, or when the user click the chat panel or a placeholder, etc. Calculates the new virtual DOM and compares it with the old one, diffing. So that calculation of virtual DOM is not actually what the phase that you show things to the user. It's in the commit phase. Third, commit phase, React applies the necessary changes to the real DOM. And then fourth, a passive effects. So after that re-render is only you would use that side effects that we keep talking about, or the dynamic dependency. So passive effects kind of like implementing first the state or the actions in that line of code before we implement that dependency, before that next action are implemented inside the app. Here we actually need an action first before we need an action first before the side effects are rendered, kind of like the opposite, because it's a side effect. So passive effects use effect after the DOM is updated and the screen is repainted. So after this screen is updated and the screen is repainted in the virtual DOM, that's the only time React runs use effect hooks. So third, summary of key behaviors. Rendering is not equal DOM updates. A component can re-render without changing the DOM by referencing that previous same state. Batching, React 18 Plus automatically batches multiple set states calls into a single render pass, meaning one update may trigger only one render and one commit. So if you have a set state, kind of like with a module with JavaScript, you basically dynamically import all the imports modules. Here with set state calls inside the module, it actually does all of that in a single pass, meaning you only have one render and commit phase for all of them. So it's batch per module. Side effects, use effects, these run after the UI is updated, ensuring they don't block user experience. Layout effects, use layout effect, these run synchronously after the commit phase but before the browser repaints the screen. So it is synchronously after the commit phase, here after this commit phase, but before the browser repaints. So it's inside the commit phase, the layout effects. Useful for measuring DOM elements. In short, render to commit to facet side effects, which is use effects. How React batches updates. React groups updates that happen within the same event loop tick. So it batches that kind of like with the same module. In this case, it actually used a one event loop tick. So automatic batching, React 18 Plus, all updates, even those inside set timeout, promises, or native event listeners are now automatically batched together. So aside from set state, even those inside set timeout and promises or native event listening are now batched or in one event loop tick as long as they're inside the same module. How it works: when you call set state, React doesn't run to the kitchen re-render immediately. It writes your request on a ticket state queue and waits for the entire function to finish before processing everything at once in one event loop tick, or in the JavaScript way, it's in one module. Second, can you control the timing? You cannot tell the React to batch this and wait exactly 15 seconds before committing. React's batching is about goofing, not delaying. So you cannot control this transition or this batch, because again, it is determined by your event loop tick. To delay the update, you must use standard JavaScript tools like set timeout or async/wait to wait before the calling the state setter. To force immediate updates, if you need the DOM to update instantly, bypassing batching, use the Flash Sync API from React DOM. So if you want to bypass this, which is not recommended, you would need to use a Flash Sync API from React DOM to communicate or bypass the DOM interaction with the committing phase. Third, how React reschedules re-renders. React uses a scheduler to manage the order and urgency of updates. First, This is actually how it managed. Instead of like timing it or bypassing it, instead of timing it uses a set type outer async slash await, or bypassing it with Flash Sync API. Here it's actually how it is being scheduled. So React uses scheduler to manage the order and urgency of updates. Prioritization, it assigns lanes to updates. A user click high priority will jump the queue ahead of a background data fetch. Low priority, so it assigns a priority in each of the state currently being in the queue. Second, time slicing. In concurrent mode, React can break a large render into small 5 milliseconds chunks. So it's like with the OS, really. So if it's in a concurrent mode, React is in that mode, it would break that small render state into small chunks. If a higher priority task like a mouse click comes in, React pauses that current render, handles the click, and then resumes where it left off. So any needed changes, state changes in React that is not observably in the moment, just like with a click, will be paused in the background. Kind of like with prioritization, time slicing with OS. Expiration, that's the third. Every task has an expiration. If a low priority task waits too long, React eventually treats it as urgent to prevent starvation. So in order, just like with an OS as well, if a low priority wait too long and it's not being executed, kind of like a process not being executed because a long process like blocks it, it will React will prioritize that to avoid starvation. Code example, the layering versus batching. Const argument count comma set count equal use state argument 0 semicolon. Next line, const handle action equal open and close parenthesis towards open semicolon bracket. Next line, these are batch, only one render occurs after this function ends. Set count argument c to c plus 1 closing. Next line, set count c to c plus d closing. Then second, to commit after 15 seconds, you delay the call, not the batch. Set timeout towards open and semicolon bracket. Next line, set time cut c to c plus 10, re-render happens 15 seconds later. Then closing comma 15,000 closing. So no, JWT JSON Web Token is not an authentication service itself, but rather an open standard and a tool used to implement authentication and authorization mechanism in application like those built with Node.js. In Node.js, libraries like JSON Web Token are used by developers to generate, sign, and verify these tokens. So in Node.js, since it's used in NPM, there's a known library in NPM that are used by developers to generate, sign, and verify these tokens that of course still need to be supported by your implementation and authentication service implemented in your backend, which is usually TypeScript. Understanding JWT in Node.js, standard, not a service. JWT is an RFC 719 standard defining a secure, compact, and self-contained way to transmit information, claims between parties as JSON object. Implementation tool, developers use libraries like the JSON Web Token package on NPM within their Node.js application logic to handle the creation and validation of tokens. Stateless authentication, a key benefits of JWT is that it enables stateless authentication. The server doesn't need to store session data because all necessary information is contained within the signed token itself. This makes it highly scalable and well suited for APIs and microservices architectures. How it works in practice: log in. When a user successfully logs in with their credentials, your Node.js server generates a JWT and sends it back to the client. Subsequent request, the client stores this token, i.e. in an HTTP-only cookie or local storage, and includes it in the authorization header of subsequent requests to access protected routes. Verification: a middleware function in your Node.js code intercepts this request, verifies the token signature using a secret key, and if valid, grants access to the requested resource. In summary, you use a Node.js library to build your own authentication system based on the JWT standard, rather than using a standalone JWT service provided out of the box by Node.js.